These are markers I use pretty often. I'm curious if the color of a marker is made of a single pigment or several, so let's do some experiment to figure it out. As you can see, I prepared a red and a blue marker. To do that experiment, I would need a strip of paper. So I just cut a strip that was about 1 inch wide from a piece of printing paper. Using a ruler, I drew 2 color bars on that piece of paper from the 2 markers. Next, in a small beaker, I added some liquid, some solvent, which is a mixture of 50% isopropanol and 50% water in volumes. Then I placed the paper strip in the beaker and making sure the end of the paper is dipped in the liquid, in the solvent. Then I just let it go at room temperature for about 30 minutes. It was pretty much finished at this point, so let's take a look at the result. So obviously, the blue bar was separated into 2 bands, a baby blue band on top of a violet band. That means the blue marker is made of at least 2 pigments, the baby blue and the violet. I think the violet gives the tone of the color, and the baby blue makes it bright. For the red color, for the red marker, you only see one bar, which means the red marker probably only has a red pigments in there. So how does that happen? How does the color separate it? So in this case, this piece of paper is called stationary phase. It's stationary because it's not moving, but the solvent or the liquid is the mobile phase because it got wicked up through that piece of paper. And while the solvent moves up through the paper, it also brings that color bar forward on that piece of paper. But during this process, the different pigments or different molecules in that color bar moves at different speeds, at different rates. So the baby blue moved obviously faster than the violet, okay? Or we call that the violet was more retained, was more stuck, was more held on that piece of paper. So based on the different migration rates on that stationary phase, which was paper, different pigments could be separated. So this is a very simple demonstration of molecular separation, and this phenomenon is actually called chromatography. And chromatography is very useful in modern research and in manufacturing, because sometimes you got a sample, like a biological sample. It will have hundreds or thousands of molecules inside of it. You probably need to separate them to identify what you are looking for or to quantify what you are interested in. There are two main types of chromatography instruments nowadays on the market. There are high-performance liquid chromatography, or HPLC, or gas chromatography, or GC. As I said, those instruments are very, very widely used, and this business has a big market. I think someone said it is $1 billion market for chromatography machines and supplies. Okay, so we're just talking about a simple chromatography today using paper and some isopropanol and water, but it's fun to see that the blue color, the blue marker, has two pigments inside of it.